This is Dr. Sandeep, working as Associate Professor in the Department of Mechanical Engineering, Institute of Aeronautical Engineering, Hyderabad. Today we are going to discuss about the heat treatment process and its different types of heat treatment process in this session. So what is the main purpose of heat treatment? So generally why we are doing the heat treatment and what are the different types of heat treatment process, and after doing the heat treatment process, what are the applications for those heat treatment material we'll discuss in the session. So generally heat treatment process is the process of heating the metal without reaching the melting temperature. That means you're heating the metal to change the mechanical properties or to get some enhancement in the properties. But what is the condition means without reaching the melting temperature. So if you reach the melting temperature, what happens? The metal get melted. So once the metal get melted, you can't do any heat treatment process there. So before reaching the heat treatment molten metal state, you have to do the heat treatment process. So that's why the heat treatment process is the heating of metal. So the name itself, heat treatment means you have to heat the metal in order to achieve the required mechanical properties. And the condition is you have to maintain the heat treatment process before the molten state. Molten state is nothing but the liquidous state. That is the recrystallization temperature. You should not reach to the recrystallization temperature. Before the recrystallization temperature only, the heat treatment process has to be done. So according to the definition, the heat treatment process is the process of heating the metal without letting it to reach the molten and the melting state. Then what you have to do, after doing the heat treatment process, then you have to cool the material again. After doing the heat treatment process, we have to cool the material and in a controlled way. That means you should not do a drastic cooling or fast cooling. In a controlled manner, slowly you have to do the process of cooling also. Why? Because in order to sustain those properties inside the body, we have to do a controlled manner, in a progressive manner, the cooling of the material. So once the material is done with the heat treatment process, then slowly allow it to cool itself so that it can sustain its own properties. So that after doing this, it will get the desirable mechanical properties. So in order to get the desirable mechanical properties to any type of material, first we have to do the heat treatment process. That means you have to heat the metal, before the molten state, and then after that you have to let it be cooled down slowly, progressively, so that you can get the desirable mechanical properties. And also heat treatment is used to either make the metal strong or more malleable or more resistance to abrasion or more ductile. That's what, in order to achieve the mechanical properties like resistance, ductile and strong, what we're trying to do, we're trying to cool the body or cool the material slowly. So because of this cooling slowly or in a controlled manner, what we're trying to get, we're trying to get the metal very, very strong. If you see here, the metal is getting very strong. In the previous, the raw material what we're getting, so when you compare the raw material with the heat treatment material, so what is happening, there is a large difference in the strength of the material. So since we are doing the cooling in a progressive manner, so first one what we are getting a strength, high strength in the metal. Also it is very, very malleable. You can do any type of manufacturing process, and also it is resistance to abrasion. Though you are giving a high amount of heat or high amount of load, it can resist to that different types of loads. And also ductile, you can bend to any type of shape. That means it is very flexible for manufacturing also. So these are all some of the benefits or the desirable mechanical properties which are being achieved with the help of heat treatment process. That's why heat treatment is very, very important in the manufacturing industry or manufacturing any type of material. So before manufacturing any type of material, first we have to do the heat treatment process. So what are the raw material we are getting from the industries? So this raw material has to be converted into one shape, some geometrical shape. So how to achieve to the geometrical shape means, first of all we have to do the heat treatment process to enhance the mechanical properties inside the material. So what are the different types of heat treatment process? We'll see one by one. So this is about the heat treatment process. Now you have the 4 different types of heat treatment process. So first one is the annealing process. Second one is the normalizing, the third one is hardening, and the last one is tempering. So these are all the four different types of heat treatment processes done in the manufacturing industry. So what are those? Annealing, normalizing, hardening, and tempering. So depending upon the type of application we need, we can select the type of heat treatment process. So as we discussed in the previous sessions also, how we are trying to select the material for any type of application. So we are trying to select the material depending upon its application. So in a similar way, depending upon the application, what type of heat treatment process has to be done to the material can be achieved by these four different types of heat treatment process. So first, if you go to the annealing, heat treatment steel. So in that, if you see annealing, so what is the main purpose of this annealing process? Is to do the opposite of hardening. The main purpose of annealing is to do the opposite of the hardening process. That means what it is does, annealing of metal relieves stresses. So what is happening? So what are the raw material we are getting? So it is having a lot of internal stresses. So these stresses has to be relieved. If these stresses are not being relieved and we are trying to do any manufacturing, what happens after some time? The cracks may form on the material of the body. So in order to control or in order to prevent those internal crack formation, the stresses inside the body has to be relieved. So how can you do these relieving of stresses? Means by annealing process. So annealing process, what does it do? It does removes or relieve these stresses inside the bodies, and after that it softens the metal. So once the metal is being softened, it is very easy for us to do any type of manufacturing process, whether it can be hot working process or cold working process or rolling process. We can do any type of cutting process can also be done if the metal is very, very soft in nature. And also it increases the ductility. So any type of different geometrical shapes, if you want to prepare, then it is very easy for us. So ductility nature is very, very important for any type of material during the manufacturing process. And also it improves the grain structures. So what are the irregular shapes are there inside the material? That is the grain structure which is being incorporated inside the body. It may be irregular. These irregularities or any improvement in the grain structure can be achieved with the help of annealing process. So main criteria of doing this annealing process under heat treatment process is first one is any stresses are inside the body incorporated. These can be relieved. The second one is it softens the metal, and the other nature is it increases the ductility of the material in order to do any type of manufacturing process, and also it improves the grain structure within the body. So these are all some of the important mechanical properties that are being developed inside the body by doing the annealing process. And also with an appropriate preheating stage, welding can lead to a metal with uneven temperatures, even molten metal areas next to the areas that are at room temperature. So what is happening during the welding process? If you are giving excess amount of temperature, or if you try to give a less amount of temperature and if you are trying to do the welding process, so what is happening? There is no proper heat treatment inside the body during the welding process. That means you're not giving a pre-heat treatment there. So if you're not giving exact heat to the metal, and if you're trying to do the welding process, what happens? The metal have some internal stresses are being involved inside the body. So that's why these stresses, what are the stresses are there? We are trying to remove those stresses by the process of annealing process. So that's why annealing is very, very important in order to remove whatever the stresses are present inside the body. And also it tries to increase the ductility in the nature of the material, and also the grain structure is being increased or enhanced or improved with the help of the annealing process. And in those circumstances, what is happening? Welding can make the metal weaker. So if you're not giving a proper preheat to the metal before the welding process, so what is happening? The metal or the weld area, wherever you're doing the weld area, gets weaker in nature. But what is a welding? Welding is a permanent joint. So if you want to do the exact welding, the preheating is very, very important during the welding process. So here, if you are not providing sufficient preheating to the material before welding, what is happening? It is making the metal very, very weak. So as the welding gets cooler. That means after doing the welding, if you try to cool the material, what is happening here? Internal stresses are being developed, where you can develop along the side of the hard and brittle spot. So you can get those stresses. So what are the stresses we are trying to remove during the annealing process? How they are created means an example of welding. So any type of metal, if you want to do the welding, we have to prepare it for a preheating. So preheating has to be done to the material in order to remove all those stresses. But in this case, if you're trying to do the welding without preheating, or if you're not giving a sufficient heat during the welding process, so what is happening? The section where the zone we are doing the welding, those zone gets very weak in nature. So because of that weak in nature, slowly if you do the cooling process, so what is happening? There is a development, there is an increase in the stresses are developed at that zone where we have done the welding. So these types of internal stresses can be removed with the help of the annealing process. That's why annealing is one of the way to fix common problems like this and relieves the internal stresses. So any type of material which is having internal stresses can be removed with the help of annealing process. So this is one of the type of heat treatment process where these internal stresses which are being incorporated or which are being adopted during any type of machinery or machining process or any welding process, the stresses can be removed with one of the type of heat treatment process that is called as a annealing process. And coming to the annealing of steels, to annealing steels and other ferrous materials to produce highest level of ductility, you must heat the metal slowly to the appropriate temperature. And it is very important that temperature of any type of preheatment or any type of welding or any type of heat treatment process, sufficient amount of heat we have to give. If you are not selecting the proper heat or proper temperature to the material, what is happening? There is so many deflections in the mechanical properties. So in order to achieve the exact mechanical properties or in order to get the desirable mechanical properties, you need to give the sufficient amount of heat for the heat treatment process. So in this case also, in order to increase the ductility of any material, if you want to increase the ductility of any material, what you have to give? You have to give the sufficient amount of heat to the material and try to let it be cool slowly slowly, then we can get the exact desirable properties. So this is one of the method of doing the annealing process. So what is happening after doing the heating to the metal to the exact temperature? That's why the selection of temperature can also be achieved, can also be selected by if you know the temperature property value. So once if you know the properties, at what temperature the metal get melted. So before getting the melting of that metal, you have to stop the temperature heating. So that's why selection of temperature is very important. So what is the basic definition of heat treatment? Before the molten state, we have to heat the metal in order to get the desirable mechanical properties. So in this case also the annealing process, in this annealing process, we are trying to increase the ductility of the material to the required temperature. So after heating, what we have to do? We have to soak it and then allow it to be slowly cooling by either burying it some sort of insulation material, or by simply turning off the furnace and letting both the furnace as the part slowly together. So this is the process we have to do. So first we have to take the raw material. This is the raw material. So we are trying to heat the material around 800 degrees centigrade. So that is the maximum temperature where the metal gets molten state. Okay, this is the after if you cross this temperature, then the metal gets into molten state. It will convert to recrystallization temperature. So this is the maximum point where you have to do the heat treatment process. So after doing the heat treatment process about 800 degrees centigrade, then what you have to do? We have to soak the material, or if you have to do any insulation, either by soaking or by doing any insulation, or if you bury the material inside and let it be cool slowly periodically, okay, then you get the desirable mechanical properties. So that is one of the technique we have to follow while doing in annealing heat shrink process in order to improve the ductility of the material. So this is one of the important property in order to achieve the ductility with the help of annealing process. So the amount of time you let the metal soak depends upon the type of material and its mass. So each individual material will have its own properties, its own mechanical properties and physical properties. So depending upon these properties, the time taking to cool the system will be dependent on the material and also about its mass. Suppose if you consider a less amount of mass or less weight of the material, and if you try to cool it down, it will take very less time. But in the same way, if you take a large amount of mass, so it will take a larger time. Similarly, different materials, the copper may take different time, silicon may take different time. Like that, depending upon the type of material, depending upon the quantity you're taking, okay, the time will vary. So the time is not constant for any type of material. So it is varying with material, varying with the quantity or varying with the masses. And if it is a low carbon steel, it requires highest possible annealing temperature, and as the carbon content increases, annealing temperature will decrease. So like that, whether it is a low carbon steel, high carbon steel or medium carbon steel, depending upon the type of steel or type of carbon content present inside the body, the time taking to cool the system will vary. So this is how we are trying to do the heat treatment process. So in this figure you can observe there is a lot of heat supplied to the material in order to achieve the desirable mechanical properties, but the material should not melt. So before the melting temperature only, you have to achieve all these properties. So after the heating this material, what you have to do? You have to make the material to cool slowly, or by just turning off the funnel, or by covering or burying with something, or by giving some insulation. So if you do all these things, that means you're trying to let the material to cool slowly by not forcing with any other substance. Then you can get the desirable mechanical properties. So this is about the annealing process. So next classification or next type of heat treatment process is the normalizing. So what is the normalizing? The purpose of normalizing is to remove any internal stresses from heat treatment machining, forging, forming, welding or casting. So normalizing, so in the name itself you have normalizing, normal. So that means you're trying to bring out the normalizing inside the body. That means again, if any stresses are there inside the body, these stresses has to be normalized. That means any uneven, if you find, this has to be come to a normal state. Okay, this is unsteady, this is steady state. So how we are trying to achieve this converting from unsteady to steady means by doing the normalizing. So this is called as a normalizing. So we are trying to get into normalizing. So what are the stresses? Because of these stresses, the material is not in a steady state condition. So we are trying to get into steady state or in the form of normalizing by these heat treatment process. So during the machining process like forging or welding or forming process, what is happening? Because of the high amount of forces are applying on the body, high amount of heat applied on the body, what is happening? There is some stresses develop inside the body because heavy load of force you are applying on the body. So because of that high load, what is happening? There are stresses inside the body which are being developed. So after some time, if he does not remove these stresses, what is happening? So this is my body. Okay. So once large amount of forces are applied on this material, so these are all the forces or the load what we are applying, F1, F2, F3 and F4 from all the sides. So it's having a lot of pressure. So these pressures has to be relieved. Otherwise, if the pressures are not being relieved, what is happening? Slowly, some cracks can be observed. These are called cracks. Okay, so in order to control these cracks, in order to reduce these cracks, what we are trying to do? We are trying to eliminate all these stresses. How means? With the help of normalizing. So with the help of normalizing, we are trying to remove all these forces so that these cracks can be eliminated. So this is how the importance of heat treatment process in any type of manufacturing industry. So wherever the manufacturing like machining process, forging, welding, or any casting process we are doing, so all these materials will undergo with some stresses. So these stresses are being removed with the help of normalizing. So metal failure can result from uncontrolled stresses. So that's why, because of these high stresses involved, what is happening? There can be result of uncontrolled stresses. You cannot control these things. So these uncontrolled stresses may damage the material. So that's why, in order to prevent all these things, we are trying to do the heat treatment process. So one of the technique is the annealing process. So normalizing steel before any hardening can help or ensure the success of projects. So that's why annealing or the heat treatment process is very, very important after doing any type of machinery process. So in this case, we are trying to eliminate the internal stresses developed during any type of manufacturing process. So what is the main difference between the annealing and the normalizing? So in the previous case also, we have seen annealing is also removing stresses. Normalizing is also used to remove the internal stresses. So what is the main difference between these two? So normalizing only applies to ferrous metals only. So that is the difference you have to know. So both the normalizing as well as the annealing process are trying to remove the internal stresses, but where these normalizing or annealing is being applied to what type of material? So normalizing can be applied only to the ferrous metals like steels. So this you have to know. Normalizing only for ferrous metal like steel. These types of metals can be relieved from the stresses with the help of normalizing. But there is another key difference in this heat treatment process. When normalizing, after the metal is heated to high temperatures, it is air cooled after removal from the furnace. Again, so after doing the heat treatment process, what we are trying to do, we are removing the material and we are trying to do cooling with the help of air cooled system. So that is what is happening in the normalizing. And the normalized steel is strong than annealed steel. So this is how, though it is having the same thing, we are trying to remove the strength wise. If you compare, the normalizing steel will have higher strength when you compare with the annealed steel. So that is the difference. Why means the cooling process, we are trying to let the system to be cooled by its own self. If you're trying to, or if you're forcing the system to cool by any other external factor, then the strength may get reduced. But here in the normalizing factor, what we're trying to do, though we are heating about the recrystallization temperature, we're trying to cool the system by itself only, so that it can does not relieve whatever the properties are there. It will incorporate with itself only. That's why the strength will not go anywhere. So that's why the strength of the metal will be very, very strong when you compare with the annealed steel with the normalized steel. So with both high strength and high ductility, it is tough than annealed steel. Again, the ductility nature, the strength is also very, very high for the normalizing steel when you compare with the annealed steel. And if the metal part needs to be withstand impact or have maximum toughness to resist external stresses, it is usually recommended with the normalized than the annealed steel. So that's why most of the materials, if the properties like ductility, the strength, all these things have to be achieved to the desirable level, then what type of heat treatment process you have to select? You have to select the normalizing type of heat treatment process we have to do. So most of the manufacturing process or manufacturing industries, we are trying to use the normalizing heat treatment process when it is compared with the annealed heat treatment process. So in order to achieve the desirable mechanical properties. And coming to the another type of heat treatment process, we have the hardening. The third type of heat treatment process is hardening. So though in the name itself it is hardening, so we can achieve the hardness of the metal, but it is not restricted to only hardness only. So that's why the intent of hardness is just not just to harden the steel, but also make it stronger. So that is what you have to identify. Though the purpose is to harden the material, and the same way it is trying to increase the strength of the material also. So that is the most importance of this hardening of steel. So while hardening, does not increase strength, it also decreases the ductility. So this is one of the drawback. What is happening when you compare with any normalizing or annealing process, there the ductility value is very high. But in this case, though the hardness or strength of the metal is increasing, the ductility nature will be decreasing. So because of this ductility nature decreases, the manufacturing process, making of any material into different shape, it will become more difficult. So that's why making the metal will be more brittle in nature. So after hardening, you need to tempering the metal to remove the some of the brittleness. So though you are doing the heat treatment process for the steels, and the steel is becoming harder and stronger, but the ductility nature is becoming very less. So because of this ductility nature, reduction in the ductility nature, what is happening? The machining process is becoming very difficult for us to do the material which is having a hardness in nature. So for this, what we have to do, again we have to do some tempering technique. So additionally, though we are doing the hardness heat treatment process, again another additional type of heat treatment process, what we have to do, we have to do the tempering process in order to remove some brittleness in the nature of the material. So this is how we have to do in the hardening process. So first of all, the hardening heat treatment process is not confined only to harden the substance, but also to increase the strength of the material. And during this operation of increase of the hardness as well as strength, what is happening? The ductility nature is coming down. So because of the ductility nature is coming down, the brittleness is also very high in nature. If the brittleness is very high in nature, the manufacturing of the metal will become very difficult for us. So another alternative method to remove some of the brittleness in nature is what? You have to go with the another type of technique which is called as a tempering process. So to harden most steels, you would use the first two stages of heat treatment. So what are the first two stages? Means slow temperature heat followed by soaking by a specific time of uniform temperature. So in order to achieve the exact hardness of the materials, we need to follow the two stages of heat treatment. So first one is what? Slow temperature heat followed by soaking by a specified time. So in the previous annealing or normalizing, what we are trying to do, we are trying to heat to the required temperature, and we are trying to let the system to cool slowly, and we are waiting up to it cools. But here in this case, in order to achieve the hardness of the material, what we are trying to do, we are trying to increase the temperature slowly and let it be cool for a specific time. We are not waiting for until the body will become cool, but we are making some specific time. We are trying to soak the material for a specific time, and we are trying to achieve the desirable mechanical properties. That is the first stage. And the third stage is different. That is what? When you harden material, you rapidly cool them by plunging them into water, oil or brine. So this is another type of things. So first one is what? Slow temperature. The second technique is what? Trying to soak the material which is being heated for a certain temperature. And the third stage is what? Rapid cooling by using some water or by oil or some brine solution. So by using all these types of things, we are trying to do a rapid things. So these are all the things where you can get harden of steels. So most steels require rapid cooling called quenching process to be hardened, but there are few that can be successfully air cooled. So most of the materials, in order to get hardness inside the body, are done with the rapid cooling only. And these type of rapid cooling is called as a quenching. And some few materials can be cooled themselves with the help of air cooled, but is naturally, if it is cooled, then also we can achieve the hardness of the material. So depending upon the type of material, whether it can be done by a rapid cooling or by cooling with the air which is being available naturally. So this is the three stages where you can get the desirable mechanical properties, that is the hardness. If you want to increase the hardness, then you have to go with this type of hardening heat treatment process. So first one is what? The first stage is what? You have to slowly increase the temperature. The second stage is what? Slowly soak the material, okay, and wait for some confined time, specific time. And the third one is rapid cooling. You have to dip the material inside the water or any oil or any brine solution. So like that, if you do, we can achieve the maximum hardness of the material for most of the materials. For fewer material, it is being air cooled. And when carbon steel is hardened, the steel must be cooled under 1000 degree Fahrenheit. So that's what, depending upon the type of material, okay, that the cooling time or the heat treatment temperature may vary. So in this case, if you are considering the carbon steel to be hardened, so what you have to do, we have to make the steel that must be cooled under 1000 degree Fahrenheit only in less than 1 second. So this is the considerations what we have for getting the hardness of the carbon steels. So we have to cool under 1000 degree Fahrenheit only. So when the material is being heated and reaching to 1000 degrees centigrade, immediately we have to cool in 1 second of time. So then you can get the hardness of the material for the carbon type of steels. But once you add some alloys, that means if you're trying to increase any other properties by adding alloys to the steel and increase the effectiveness of the carbon, you have to increase the time limit beyond 1 second. If it is a single carbon steel, then within 1 second you have to cool the system after reaching the 1000 degree Fahrenheit. But if you are adding any alloys to the carbon steels, then what you have to do, you have to wait beyond 1 minute of time or 1 second of time, and you have to do the cooling process. So that's what that allows you to select slower quenching medium to get the specific hardness. Why we are trying to do beyond the 1 limit time means 1 second time is, you have to get the specific hardness. In order to achieve the specific hardness, you are maintaining some slower quenching process to get the desirable hardness of the material. So if it is a single or a alloy type of thing, there is a difference in the time also to get the hardness of the nature of the material. And typical carbon steels are quenched in brine or water, whereas alloy steels are quenched in oil. Again, so whatever the carbon steels are there, if you are trying to cool them, then you have to use whether by water or any brine solution. But if it is alloying with any other type of elements, then you have to use in oil. So there is a difference you have to maintain. So that's why you have to know, you have to study the what type of material you're using for what type of heat treatment process. So if it is a completely carbon steel, then you have to go with the water or the brine solution to cool the system. But when the carbon steel is composed of some alloys, then you have to go with the oil in order to get the cooling. So quenching is the process that produces very high internal stresses, and to relieve these stresses, one option is tempering. So that's what, though you're trying to do the quenching process and trying to cool the system and trying to increase the hardness, but during this fast cooling process, lot of internal stresses are being developed inside the body. Again, these internal stresses, what are the internal stresses are there? These can be again removed or can be absorbed by using the tempering. So this is one of the other method we are following in order to reduce the internal stresses developed during the hardness of the material. So right before the part becomes cool, you have to remove it from the quenching at a temperature of 200 degree Fahrenheit and let it be cooled for air. So that's what, depending upon the type of material, here what we are doing for the carbon steels, when it is coming to 1000 degree Fahrenheit, we are trying to cool the system by 1 second. And if it is alloying with any other element, then what you have to do, beyond 1 second we have to wait and then we have to cool. And again, if it is done with some tempering process, then we have to do the quenching process at 200 degrees centigrade and let it be cool with air. So there is a process we have to do during the hardness of any material to increase the strength of the material. Then what is the last type of heat treatment process is tempering. So tempering we are trying to use to remove the internal stresses developed during the hardness of any material or normalizing conditions. So after you harden any material, whether it is maybe by a flame or any temperature we are giving, internal stresses are being developed during the rapid cooling process only. So since we are doing rapid cooling by 1 second, after reaching the 1000 degree Fahrenheit, immediately we are trying to cool the system. That type of process is called as a rapid cooling. So during this rapid cooling, what is happening? There are a lot of internal stresses developed inside the body. So in order to remove those internal stresses, we are trying to do the tempering process. So during the rapid cooling, inherent in the process. Steel is often both harder that need to be too brittle. So because of these things, what is happening? It is becoming very, very brittle in nature. So high stresses are developed inside the body. So if the body is being developed with high stresses, from all the directions, so what is happening? It is becoming very, very brittle in nature. You can't do any manufacturing of the metal. It will immediately break. So these brittleness can be removed with the help of tempering process. So how they are created means, because of this rapid cooling, lot of stresses are being developed inside the body, and because of the lot of stresses, there is a huge increase in the brittleness of the nature. So all these things has to be removed with the help of tempering process, that is tempering heat treatment. So the answer may be to temper. So if you do the tempering heat treatment process, then all these internal stresses can be removed and relieved from the body. So what happens during this tempering process means heating steel to a certain temperature below its hardening temperature. So though it is a heat treatment process which is called as a tempering, this temperature has to be reached below the hardening temperature only. What is the hardening temperature? Again, these hardening temperatures vary with the material. So depending upon the type of material, the temperature of hardness varies. So that's what we have to maintain the hardness temperature below the hardness value. So first of all, we have to maintain, we have to set up a temperature below its hardness value. Then you can achieve the tempering process, and you can try to relieve the stresses from the body. And after that, hold the steel at that temperature for a specific time. So after reaching that hardening, below hardening temperature, you have to hold that material for a specific time period. After that, cool the steel, typically in still air. So if you do all these stages during the process of tempering, you can remove all the internal stresses provided or inherent in the body. So first of all, you have to heat the steel and to set a temperature below the hardening temperature. And after that, you have to maintain for a specific period of time, and then allow the system to be cool for some time and kept for the air. So these are the process you have to follow when the tempering of a heat treatment process. When you temper a steel part, you reduce the hardness that was caused during the hardness which was developed. So what is happening? Though you are trying to remove the internal stresses developed by the hardening heat treatment process, we are trying to reduce the hardness also in the same way. So stresses are being relieved, but slowly the hardness is also becoming reduction in these things. So tempering always follows the hardening, and while reducing the brittleness, it also softens the steel. So what is the things we are getting in the tempering process? So tempering is trying to remove the internal stresses so that the brittleness will get reduced and the strength is increasing, and also the metal is getting softened in nature. So if it is getting softened in nature, that means the ductility is increasing. The manufacturing of these metal can be very easy for us to during any type of manufacturing process. So what is happening here? The amount of hardness you lose can be controlled based upon the temperature during the tempering process. So though you're trying to remove the brittleness, though you're trying to remove the internal stresses inside the body, simultaneously the hardness is being getting reduction. The hardness of the material should not come down. So in order to again compensate this hardness of the material, we are trying to increase the temperature during the tempering process. So just knowing that tempering relieves the stresses by quenching, reducing of brittleness and hardness can actually increase the strength also. So though it is reducing the brittleness and increasing the ductility and reducing hardness, again here the tensile strength is becoming very, very high. So that is the other thing what we can achieve. That means some properties may come down, but some mechanical properties may increase. So during the tempering process of any steel. So these are the steps you need to follow for any type of industry or any type of manufacturing process during the heat treatment process. So what are the steps here? First we have to load. Loading means the material what we are getting, the raw material. You have to first clean them, pre-wash with some solutions, dephosphate them and spray rinse. So after this, you have to go with the heat treatment process, the main thing what we are discussing today. So here heating, we have to do the heating process to the material to remove all the stresses developed. So first what we are doing in the heating, preheating the material, then we are heating with the different types of quenching methods, then we have to soak and diffuse, and then you have to do the pre-cleaning process. So after that, quenching process we are doing. That means we are trying to cool the material themselves. And then tempering, surface coating, and unloading. So loading and unloading, in between these we have a lot of heat treatment operations are going on to get the desirable output with desirable mechanical properties. So these are all the things you need to follow for any manufacturing process, from the raw material to the output. And if you see the applications of the heat treatment in metallurgy, we have a lot of applications in automobiles. What are the spare parts which are being available for the all type of automobiles are done with the heat treatment process. Why? Because it should have a good mechanical properties and chemical properties during the operation. So that's why most of the spare parts for the automobile engineering are done with the heat treatment applications only. And similarly, the aerospace parts are also done with the heat treatment process. Heat treatment process means different types of heat treatment what we have discussed, like quenching, annealing, hardening, normalizing. So any type of heat treatment process can be done. So all the process cannot be incorporated for a single application. Okay, any one it can be taken, and depending upon the application we can select what type of heat treatment process is required. And for the computers, metalworking, machinery, and construction. So all these some of the categories where the heat treatment applications have a wide range depending upon its application as well as the material which is being selected for these applications. And these are some of the differences where you can get the information about the heat treatment process. First one is the introduction to physical metallurgy. Second one is essential of material science engineering. Third one is material science and metallurgy. And the fourth one is material science and engineering. So these are all the references where you can get the information about the heat treatment process. So any type of material which has to be manufactured has to undergo the heat treatment process. So how to select the heat treatment process depends upon the type of material, and also depending upon the type of application we need, you have to select the heat treatment process, and also what type of property we have to have. Okay, that also depends upon the type of heat treatment process. So all the heat treatment process cannot be incorporated as a single material. Depending upon the application, depending upon the property, you need to select the what type of heat treatment process is required to the given material. So this is about the heat treatment process, and thank you for the session.
Like, share and subscribe. Hit the bell icon for more updates.